Right now, inside a high-security facility in the Netherlands, a single machine is generating a sustained environment 40 times hotter than the surface of the sun. It is the only reason the device in your hand exists at all. 50,000 times every single second. A laser detonates a droplet of molten tin, smaller than a grain of pollen. In the exact same machine, a separate mechanical stage slings a silicon wafer back and forth at 32 Gs, more than 3 times the force that makes a fighter pilot black out. It has to land within a fraction of a nanometer every single time. Which is exactly why the United States government stepped in and legally prohibited this machine from ever entering China. It is not classified as a weapon, it is a leash, and if this single engineering bottleneck ever fails, the global balance of power changes forever. In February 2023, ASML quietly admitted something buried inside a routine annual report. The kind of document nobody reads except corporate lawyers and compliance officers. A former employee, based in China, had pulled out confidential data from a system called Team Center. This isn't just an app. It's the internal digital vault where ASML stores the highly classified technical guts of how its machines are actually built. It wasn't a blueprint stolen off a desk. It was a repository login containing 2 million lines of source code from a related case ASML had already fought in court. The company called it not material. The Dutch government called it economic espionage. We are going to come back to this login screen because it's not just a footnote. It is the entire point. A single company spent 40 years building a physical machine monopoly that literally no other company on earth can replicate it. And the most dangerous threat to that laboratory wasn't another lab or another research tech or anything. It was a login and a password. To understand why that login is treated as the NASA security itself, we have to look inside the vault itself. What was it inside actually that made the login and password so critical? Once you see what this machine forces physics to do, you will understand why a single leaked credential is treated like a declaration of war. A nozzle inside a sealed vacuum chamber, located in a quiet industrial park in Veldhoven, Netherlands, a town most people couldn't find on a map. It fires a continuous stream of molten tin. Each individual droplet is exactly 25 microns wide. For scale, that is roughly a quarter of a width of a single human hair. You could fit 4 of these droplets side by side, like on the same strand of hair, and still have some room left over. The droplet falls at 70 meters per second, 240 kilometers an hour. That is faster than a Formula 1 car at full throttle. And waiting for it in the dark is the largest industrial laser ever built for a single purpose. It doesn't just fire once, it strikes twice, in sequence, mid-flight, targeting a speck smaller than a pinhead moving at highway speeds. The first pulse is almost gentle, like a pre-pulse. Its only job is to flatten the falling spear into a paper-thin disc, like punching a water balloon just hard enough to flatten it without bursting it. The timing must be down to the microsecond because this actual flattened disc is about to become the real target. And then, a fraction of a microsecond later, the second pulse hits at full power. The tin doesn't melt, it vanishes into plasma, 240,000 degrees Celsius. That is 40 times hotter than the surface of the sun. A literal star, recreated for literally a microsecond that you wouldn't even notice, and you could walk past it even in a parking lot. When that former employee breached the Team Center vault, they weren't just looking at schematics. They were looking at the code required to govern this exact sequence: droplet, pre-pulse, kill shot, plasma, 50,000 times every single second, running continuously in Taiwan, South Korea, and Arizona right now. Nobody designed this process to be safe. They designed it to be barely survivable for the machine itself, so the machine could even break at any point. Because what that plasma explosion unleashes next is an engineering disaster ASML still hasn't fully solved. That plasma blast doesn't just generate the extreme ultraviolet light needed to etch microchips, it creates shrapnel. Every single detonation throws high-energy thin ions and molten debris straight into the only surface forced to take the hit. The collector mirror, 50,000 times per second. This multi-million-dollar optical surface is sandblasted by material hot enough to vaporize steel. By any normal engineering logic, this should not even last any single operational shift. But here's why it does. This mirror, built by Carl Zeiss SMT in Germany, is the most precisely manufactured surface human beings have ever engineered. If you scale this single mirror up to the physical size of the entire country of Germany, the tallest microscopic bump anywhere on this surface would be a mere 1/10 of a millimeter, thinner than a single sheet of paper. Scale a space telescopic mirror up the same way, and its imperfections would stand 2 centimeters tall. This collector is 200 times flatter than the glass we use to photograph deep space galaxies. 200 times. And yet, the atomic violence still wins. A contamination layer, even if it's just 1 nanometer thick, a film thinner than the wall of a soap bubble, slashes the mirror's optical performance by 20%. It takes exactly 60 seconds for that degradation to even happen. Think about that. A masterpiece of atomic scale polishing ruined by the dirt you cannot even see in the time it takes for you to watch this section of the video. Somewhere in a semiconductor fab right now, a technician is suiting up in a full body suit with positive pressure airflow and a checklist longer than a commercial pilot's. One stray skin flake or a single particle smaller than what users excelled means a wafer run worth thousands of dollars is dead before anyone even realizes it. That isn't a hypothetical warning. That is a standard Tuesday for someone working in a fab that you have never even heard of. So, how do you even keep a mirror dying every 60 seconds? How do you protect it? ASML's solution is absurdly bold. They flood the entire vacuum chamber with hydrogen gas. The hydrogen chemically reacts with the rogue contamination, scrubbing it off the mirror automatically while the machine continues to fire. It sounds simple, or maybe it doesn't, but it works perfectly, and it has been working perfectly for the past God knows how long years. And that's how they have been able to keep the machine from destructing itself. If that wasn't the case, it would die every minute. This machine is just insanely vulnerable to that kind of things. But there is a catch. That same hydrogen gas is blasted by the ultra-powered EUV light it's meant to protect. The light ionizes the gas, turning the hydrogen into a second reactive plasma, one that can blister the mirror coating from underneath and introduce something every engineer inside that facility is trained to fear: the permanent standing risk of a hydrogen explosion inside a sealed chamber. ASML never really truly solved the self-destruction problem, not yet. They just simply manage the way like a truce around it, or like a workaround it. A workaround, or the truce, that they have to win every single minute and forever. Or a machine that costs an inventor like $380 million becomes completely useless, worthless. $380 million. And all that plasma chaos that we just walked through on that is just the top layer of it. The bottom half of the machine actually has to use that light now. Underneath the optical path rests the mechanical stage holding the silicon wafer, waiting for its exposure. In ASML's newest high-NA systems, this stage doesn't glide, it violently slams. It accelerates and decelerates from 0 to 100 km/h on a tenth of a second inside a hard vacuum, pulling 32 Gs of force. Fighter pilots train for years to survive 9 Gs before blacking out. This mechanical state pulls more than 3 times of that threshold. If it misses its intended marking by an amount of smaller than a few atoms stacked together, the circuit design fails. The chip dies and a multi-thousand-dollar wafer becomes garbage as the next one moves into position. That type of knowledge, the exact calibration required to keep a machine from falling apart at 32 Gs, is why that login credential makes it even more important. It's that knowledge there. It's the source code. It's the origin of it. It isn't because an adversary can just copy the blueprint and just replicate an EUV. It's not that simple. You need the physical working of all those 40 years of the time ASML has spent, and to carefully engineer it into the new machine. They can't just copy it. No, they can't. That's why the team set up Vault app or the data center, the login credential. It holds that much data. It holds that much power into it. It contains the calibration logs. It contains what were the failures, what were the shortcomings when they were trying it, and those very specific why this version failed, why this worked. You need those things in manufacturing a machine that can self-destruct itself in 60 seconds. That is the knowledge it holds. And ASML has spent decades learning this the hard way. Imagine how much they have actually wasted. You can ban a physical shipment. Yeah, you can certainly ban exports, imports, whatever they call. And you can block a trade sale. You can block oh, I don't want to sell to you, as this country can't sell to you, whatever. US does their things, they have the tendency to just come in between of everything. It's alright. But there's one thing they cannot do. You cannot easily block the institutional knowledge that has passed down from the last 40 years that has slipped through the login screen. The guy has gotten it. And that brings us to this core illusion of this geopolitical battle. Because the story of how this one machine was built is not really about one company building in Netherlands. It is about a hyper-distributed, fragile global web of monopolies. And as you are about to see, the entire apparatus is held together by an incredibly small number of hands. Here's the part that nobody mostly tells you about this. ASML doesn't really build most of this. They don't have the bigger hand in here. The company, whose logo is stamped on the outside of this 180-ton chassis, manufactures somewhere between 10 to 20% of the components inside. The other 80 to 90% comes from the outside. It is sourced from over 5,100 highly specialized suppliers scattered across a dozen international borders. And crucially, almost every single one of the companies are the only entity that can actually build this themselves. So this machine is complicated, to say the least. And ASML is not a traditional manufacturer. This is exactly the physical integration point that all of these companies have to be friends or shake hands together. Which means the real geopolitical question was really not how does even ASML build this thing? There is nothing. They can't really build this on their own. It is what happens when even one of those companies goes oh, I don't want to deliver this thing, or I want to stop doing this thing. What happens to the global economy when 5,100 suppliers, even one of them stops doing this? We already made Carl Zeiss SMT in Germany, the sole source for the ultra-precise mirrors. Now meet the second critical monopoly, Trump F, based in Shenzhen, Germany. They built a 10-ton carbon dioxide laser used to detonate the tin droplets. This single laser module is made of 450,000 individual parts. For perspective, a commercial Boeing 737 passenger jet has roughly 360,000 parts. The laser system required to ignite a speck of tin smaller than a pollen grain has significantly more components than a commercial airliner. And the third vital piece doesn't even come from Europe at all. It comes from Cymer, located in San Diego, California. An American firm that ASML was forced to buy for $2.5 billion because absolutely no one else on Earth was able to figure out how to perfectly synchronize 50,000 droplet explosions a second with commercial manufacturing consistency. 3 proprietary technologies, 3 distinct nations. None of them can actually build the machine by themselves. And yet, everyone has to be on the perfection side of things. Like they have to hit every single thing with perfection in order for this machine to even run. If not, the whole company in Veldhoven freezes. There's really no point of that that shit ton of like 180 ton chassis if even one of the parts is not running. But there is one thing. There's one hidden choke point that should make you worry far more than any hardware system does. Because it isn't mechanical, it's chemical, and outside the semiconductor industry, nobody really talks about it. The extreme ultraviolet light does not carve the silicon directly. Instead, the wafer must first be coated in highly specialized light-sensitive liquid chemical called the photoresist. When the light strikes this film, it alters its chemical solubility, allowing the foundry to etch the circuit lines. Without this specific chemistry, the most expensive machine on Earth is entirely useless. It becomes nothing more than a $350 million flashlight. That is an expensive flashlight if you ask me. At the leading edge of physics, the exact chemical formula qualified to handle EUV wavelengths, there are effectively only 3 companies left on Earth: Tokyo Oka Kogyo, JSR, and Shin-Etsu Chemical. All 3 are Japanese, and together they control over 90% of the total EUV resist market. 90%. 3 companies and 1 island nation. And unlike a mechanical valve, you cannot just swap chemical vendors if a supply line experiences a hiccup. Qualifying a brand new photoresist at an advanced fab requires upwards of 12 months of grueling, highly collaborative engineering to get the chemistry, the scanner, and the atomic node to align perfectly. It isn't just a simple purchase order, like whoever places the order gets it right and done. It's not simple as that. Let me just put that outright. And whoever controls those 3 chemical plants holds a countdown timer that a rival nation cannot fast forward, no matter how many billions you throw at it. This isn't a hypothetical economic theory. This exact weapon has already been fired once and hit a country nobody expected. In July 2019, during a bitter diplomatic dispute, Japan suddenly restricted the export of advanced photoresist and 2 other foundational chip-making chemicals to South Korea. Not China, South Korea, the home of Samsung and literal backbone of the global tech economy. For months, the most vital electronic supply chain on Earth watched its production inventory tick down to the single digits because a chemical shipment was held at a customs dock. Imagine elite engineers watching their remaining chemical inventory dry up day by day, knowing it takes nearly a year to qualify an alternative formula. That isn't a standard supply chain delay. That is an economic hostage situation. By July 2023, the exact same lever was pulled at the global level. Japan placed 23 categories of advanced chip-making hardware under strict export licensing restrictions. For China, it functioned as devastating de facto hardware ban. But just the hardware restrictions weren't the final move. In November 2025, Japan went directly after the chemistry itself, placing 12 core semiconductor materials, including the EUV photoresist, which broke down, under direct export restriction, naming 42 specific Chinese companies outright. Within weeks, one of Japan's leading resist giants reported that its China-bound export had collapsed by over 40% in a single month. The physical machine in Netherlands didn't have to move an inch. Didn't. There was no need. The entire infrastructure of the next tech war was choked off before the actual hardware could even leave the lab floor, which leaves every nation outside this exclusive trade alliance facing a brutal engineering dead end. If the global supply chain is locked down, why can't you just reverse engineer the pieces yourself? Here's the raw, uncomfortable truth behind this, like under this geopolitics. Let's say, even if a rival government disassembled an EUV machine down to its atomic particles, it would still be impossible to replicate this. We have to understand that. I mean, they could just replicate, but it just wouldn't work. And not because the blueprint isn't classified, like it's gonna be fake or like it's not gonna be truthful, but you need those 40 years of tacit knowledge to make these atomic particles work. This is a very complicated machine, and that data doesn't live inside a text file. It lives entirely in the muscle memory of an optical polisher in Germany who can fill a sub-nanometer flaw with their hands. It lives in the proprietary chemical recipes of chemists in Tokyo who tune molecules to match a specific fab's ambient room pressure. You cannot reverse engineer 40 years of institutional knowledge failures in a single generation. But here's what should keep you up at night about this global crazy monopoly. This machine that is built by 5,100 suppliers, like all of this crazy techs. A machine this hyper distributed with 5,000 suppliers, a dozen borders to cross, and zero redundancy for its most critical components isn't just impossible to replicate. It is catastrophically fragile, very fragile. One raw material delay in Germany, one chemical batch that fails validation in Japan, or one export license that gathers dust on a desk in Veldhoven is all it takes to halt the technological process of this entire world. And that acute vulnerability is exactly why the battle lines were drawn. Because while the engineers were focused on solving the physics of lasers and plasma, the decision to weaponize this machine was made far away from any clean room. It was decided inside a secret briefing room in Washington, based on a single realization about a national 5G network rollout that hadn't even broken ground yet. In late 2017, a warning landed inside the White House National Security Council. It didn't warn of a missile launch or a financial crash. It warned about cellular towers. The warning was simple and brutal. If a single state-backed Chinese company, Huawei, won the global race to build the 5G infrastructure first, China wouldn't just be selling hardware. It would hold a permanent structural advantage over the communications backbone of half the planet. You cannot out-subsidize an entity that has no shareholders to even answer to. So Washington even stopped to even try to compete in that race. They went after the atoms instead. Every line of code Huawei would ever write had to eventually be etched onto a physical piece of silicon, and the most advanced version of the silicon could only be printed by one machine, built in one town in the Netherlands. The United States didn't really need to build a better network. It needed to lock the gate from which the actual network was about to be built or was supposed to be built. The first move was purely bureaucratic. Washington pointed directly at Wassenaar Agreement, a treaty signed by 42 nations to stop the proliferation of dangerous dual-use technologies. The logic was simple. A lithography machine capable of printing the microchips inside next-generation military hardware isn't a factory tool anymore. It is a strategic asset. But the Wassenaar Agreement is voluntary and has no real enforcement teeth. While diplomats argued over legal definitions, a Chinese state-backed chip maker called SMIC had already placed a real order for a real EUV machine with a real shipping date. The treaty alone could never stop that vessel. Trust me, it couldn't. So United States went around it, utilizing a much sharper tool available at their own legal arsenal. In April 2018, SMIC placed its order with ASML for a single EUV machine, $150 million. Delivery was expected by the end of that year. It never arrived. And what happened next wasn't a public press conference or like a diplomatic trade ban. It was something much colder. According to the multiple Reuters reports, the US Secretary of the State personally flew to the Netherlands and told the Dutch Prime Minister directly that this specific shipment endangered common security interests. Over the following months, Washington held at least 4 separate private sessions with the Dutch officials, pressing the exact same point. The Dutch government never really rejected the SMIC's export license outright. It didn't. It just never approved it. The paperwork sat on a desk. It was always there. The renewal request stayed permanently under review. By 2019, the license simply lapsed, left to expire without a single public explanation, and ASML has not shipped one single EUV machine to China after that. 7 years, $150 million, signed and finalized, killed by a bureaucratic process so quiet that no government ever had to admit on the record that they had killed it. The diplomatic pressure worked once, right? It worked once, but it relied entirely on the personal relationships that they had. It wasn't just like a permanent system. Oh yeah, from now on we're gonna do this or like that. It was just a personal thing at that time. So, US trying to be the smart cunts here. Over the next several years, Washington built one system, the Foreign Direct Product Rule. Think about the sheer audacity of this mechanism. This actually means like what they were trying to do here is like, if a product is manufactured anywhere on earth, under any flag, in any country, any desert, any island, whatever, blah blah blah, and its creation relies on a defined threshold of American software, engineering or components, the United States claims total legal jurisdiction over where the product is allowed to go. Remember the ASML slideshow that I talked about 2 chapters back? The critical module that detonates 50,000 tin droplets a second is built by Cymer in San Diego, California, American soil, an American company. Even though it is wholly owned by a Dutch firm, it remains American in the eyes of this rule. In 2020, the United States used this exact mechanism to cut Huawei off from semiconductor chips made anywhere on earth using American tools. Even chips manufactured entirely outside the US by foreign companies for a foreign customer by 2022. That same architecture was expanded to cover entire categories of advanced computing and chip making hardware headed to Chinese borders. The message to ASML and global tech supply chains was never subtle. Keep selling to restricted markets and Washington can make your entire supply illegal or like a redundant overnight without ever setting foot in your factory. Man, that is crazy work. I mean, I thought it was only about the oil in the US, man. Really. I thought it was only about the oils. In October 2022, the blockade stopped being an abstract corporate issue and hit actual people. New US Department of Commerce rules barred American citizens and green card holders from supporting chip production at advanced fabs inside China without an explicit government license. ASML immediately issued an internal directive telling its entire US staff, citizens, permanent residents, and foreign nationals living in the States to cease servicing all Chinese customers immediately. For the executives and engineers living in this, it wasn't a theoretical process. Chinese American executives, like people who have spent years and years of their life building and spending time with this company, grabbing the knowledge, this tacit knowledge that it really requires, suddenly face the choice with no clean escape plan. Like keep doing the job they have like now expertise in, they have like spent so much of their life in, or leave the passwords back. And due to this, some research tech firms pulled off all the American tech staff overnight, like from the research divisions, like just take them off immediately, just to remain inside the law. There was no dramatic ticking clock on the screen, just a quiet, grinding choice playing out in HR departments and immigration offices person by person. By 2023 and 2024, the architecture widened again, restricting all the DUV machines and eventually cutting off maintenance, servicing, and software updates for equipment Chinese firms had already paid and operated. So, is the leash finally locked down? Here's the uncomfortable answer. Nobody is fully sure, including the people enforcing it. Just this month, in June 2026 alone, the US Commerce Secretary personally raised urgent concerns directly with ASML executives that an advanced lithography system or critical technology tied to it might have quietly slipped into China despite every restriction on the books. ASML was forced to issue an unusual public statement denying the claim, insisting that no EUV system and no EUV specific component has ever reached a Chinese customer. The Dutch government backed them up, stating its export controls are enforced with absolute strictness. After nearly a decade of international treaties, licensing fights, citizen ultimatums, and a legal rule so aggressive it overrides foreign sovereignty, the world's most powerful government, I'll give them that right now at this point, is still worried that something is getting slipped through, something is getting passed by. The actual blockade didn't make the leakage impossible. It didn't. It just made everyone nervous enough to actually keep checking what else is going on. If there will be a bit of doubts or nervousness, what else might have slipped through. And you have to understand this. When you corner a superpower, like China is a superpower, you have to give them that. This hard for this long, they're not gonna sit still and accept the containment. You know what I mean? If you just deny a country from getting to the future, it doesn't mean they're not gonna get there. Like China, Shenzhen, China, Chongqing, those cities, like China is a very advanced country. Yeah. What you do if you do this is you just simply force those mega mines there in China to like build it themselves. And I'm sure like if they can do it, like if some companies can do it, if there's any country on earth like that, I can fully have faith that they can build anything, it's China. And what US has done here is I feel like given them like a push to develop yourself, or you don't get it. But while doing that, the US indirectly is making them more capable. You know what I mean? They were just dependent before, but now they will try to build it themselves. And I think that's what happens. And that's what happened. When Washington locked the gate to Veldhoven, the global consensus among the Western tech analysts, or like whatever you call them, was simple. China's domestic semiconductor capabilities would permanently freeze at 14 nanometers node. That's what their analysis was, right? And like I said before, when you corner someone like that, like for so long, 7-8 years, they're not gonna be against to try to get the future, right? They will try to get the future. They will try to be the advanced. Like it's one of the advanced countries in the planet. And their analysis was simple. Without ASML's EUV scanners, hitting the single nanometer node was practically impossible. You needed that machine to get to that single digits of nanometers. Sometimes engineering is not just about elegance. Sometimes it is about sheer, brutal willpower. Imagine trying to draw a line so thin it can only be seen under an electron microscope, but you are forced to use a thick, blunt marker. If you draw that line once, it's too wide. But what if you draw parallel lines? Chemically etch the gaps, deposit a spacer material, and repeat that entire sequence 3 or 4 separate times just to shave down the distance between the tracks. This is called self-aligned quadruple patterning, and it is the architectural equivalent of performing an open heart surgery with a butter knife. Deprived of EUV light, Chinese state-backed foundries took their existing, unrestricted deep ultraviolet machines, tools designed for much older generations of hardware, and began running the silicon through them over and over and over and over again. It is an engineering nightmare. It destroys factory yields, meaning like how many chips you build and how many chips you try to get out, like almost 70 to 80% is garbage. So that is pretty much fucked up. The factory yield is just not there. And with that, the production cost rises very high into the stratosphere. By any metric of like capitalism, this is unsustainable. Literally can't do it because that is a large amount of wastage. But you have to understand, when a state is fighting this tech containment war, these kind of yields or like these kind of traditional metrics of capitalism doesn't really apply. The state subsidies observe the loss. And in August 2023, the world woke up to a profound geopolitical shockwave. A brand new Huawei flagship smartphone running on a domestic 7nm processor. The blockade hadn't frozen the node. It had just forced the target to spend whatever it took to break through it. But there's another catch. Quadruple patterning an older machine is just like putting a band-aid. It's not gonna do much. You literally cannot use a blunt marker to get to that 2nm frontier. To get there, you absolutely need that impossible 13.5nm light. So if you cannot buy the machine, like 180-ton chassis of that machine, how do you actually get the light? You build a particular accelerator ring. Chinese research institutes have actively filed patents and broken ground on an entirely alternative approach to lithography. Instead of using a laser to detonate individual thin droplets into a mobile scanner, they are circulating a relativistic electron beam around a particular storage ring with a circumference of roughly 100 to 150 meters, about the size of 2 basketball courts laid end to end. The concept is called steady-state microbunching. The theory: a continuous high-power stream of extreme ultraviolet light with multiple chip fabrication lines arranged around the accelerator ring like spokes on a wheel, all drinking from the same central source. Don't miss this staggering state of the structural shift. While the West spent 40 years trying to build and trying to perfect a machine that can be transportable, get into clean room, that is kind of the pinnacle of the engineering of nanometer process. Their rival is testing whether you can replace it with a stationary shared power plant instead. Light made once in one place and distributed outward to dozens of production lines simultaneously. It is wild. It's actually fucking wild. And as of right now, nobody, including the physicists building it, knows for certain it can hit the extreme stability of commercial chip demands. But it really proves that the Leash didn't really stop the pursuit of physics. It just forced it to decentralize. Which brings us straight to right now. And it's pretty ironic, to be honest. The ultimate irony of this semiconductor blockade is that it achieved exactly opposite of what it was supposed to be. China was supposed to be banned and like all and like this and all, but somehow they made them even stronger. I mean, yeah, it's China, but yeah, whatever. You have to understand, for decades, like however it exists, Chinese companies and like Chinese manufacturers, they were perfectly fine outsourcing it. But Washington pulling the lever on that foreign direct route, like whatever the name was, they turned the global supply of like a simple machine into like a geopolitical coercion. United States handed their rivals the ultimate catalyst: total necessity. And from now on, every Chinese fab, every Chinese startup, every university lab knows that if any of the components has like an American thing in that, it's gonna take them less than 24 hours for them to like ban it or stop them from using it. And now the mandate has changed from inside the Chinese borders have changed from just build the chips to de-Americanize like these things, like just stop relying on those things. And I think this this made like a global, this made a big shift in China. We like to look at our modern world and like to think, oh, we're moving through something entirely unique. And sometimes I tell myself, this is an absolute pinnacle of being a human being. And sometimes, like after reading, researching through this story, I can't help but think like whoever holds that key to Veldhoven, like if one country ever does it, will hold the future for as long as we can remember. But history doesn't look at technology. History looks at patterns. 400 years ago, the British Empire guarded the secrets of mechanical textile loom like a nuclear launch code. Exporting the blueprints or smuggling the machinery out of the country was a crime punishable by death. They thought they had permanently locked the gate to industrial civilization. Then, a 20-year-old apprentice named Samuel Slater memorized the entire design, boarded a ship to Rhode Island under a fake name, and built the American textile industry entirely from memory. The leash always breaks because a monopoly is not really a permanent state of nature. It is merely a temporary delay. ASML literally solved the physics to get the light to the real world. But in doing so, they engineered a machine so complex, so fragile, and so bottlenecked that it forced the entire empires of the earth turn the science into a cheese. The battle lines of the next century aren't being drawn on any maps. Let me tell you that much. They are being etched, line by line, invisible into the silent, weaponized architecture of the sand. Thank you for watching so far. This wasn't an easy video to make. This took quite a bit of research, quite a bit of shooting, editing. How long? I don't know how long it's gonna take to even get this video out, but I hope I did a good job. And I just want to tell you that I'm just not just trying to make any content here. I'm trying to make something that is genuinely worth watching, that is genuinely worth your time. And I appreciate you guys, like whoever have stuck for so far, so long. I don't know how long is this video gonna be. Maybe an hour, like I don't know. I appreciate you guys. I have a really shit retention rate. I don't know what I'm doing wrong, but whoever sticks to this, I'm very thankful, very grateful. It really takes a toll on me, like to make this kind of long videos. So I really appreciate if you guys give me honest feedbacks where I'm going wrong, if there's any mistakes. Yeah. I think if you just let me ramble, I'll ramble too much, so I'll just stop here, and I'll be back with a new banger in the next one. Bye.